and their order. In other words, let's have a look at all the components here that equal x cubed. Let's have like x cubed components, because they are going to relate directly to the x cubed components of the bits that we've done. In other words, I'm going to collect up, let's say collect up all the x cubed bits in this expanded form of this. So I've got ax cubed up the front by itself, and now I want to collect up all of the squares. So I've got bx squared and nothing there. Now there's nothing written up here, but now let's collect up all the x's, because even though it may not be written in here, we do have 0 x's in that, and that will be proved significant, and I'll show you why. Here I've got 6bx and cx here. I've got those two covered, I've got those ones covered. And then I've got the rest of, which is 9b plus 3c plus d. Now the reason why I'm doing that, because I know that ax cubed is going to relate directly with that x cubed. In other words, I know that because there's no other cubics of x here, I know that ax cubed equals x cubed. And if ax cubed equals x cubed, therefore a has to equal 1. And here I see that bx squared links directly to minus 2x squared. Therefore, bx squared equals minus 2x squared. Therefore, b has to equal minus 2. Because there's no other x squareds down here, so that has to be linked to that. Now, as I said before, 0x is significant here because I've got a strange thing down here. I've got 6bx plus cx equals 0 x's, because they obviously have to equal nothing because there is no x's to the power of 1 in our original polynomial, so they have to equal 0 in this case. So 6b plus c times x, all I've done is factorize that, that has to equal 0. And I also know that b equals minus 2. So 6 times minus 2 plus c has to equal 0. The x's can cancel out. So minus 12 plus c equals 0. Therefore, c has to equal 12. Oops. Now, going back up here, I know that this is now sorted. We've dealt with that. So the rest of what we're dealing with, we've figured out a, b, and c. The rest of what we're dealing with, 9 times b plus 3 times c plus d, all of those have to equal the leftover, which is 5. And I'll write this down the bottom here. 9b, plus 3c plus d equals 5. And I also know what b is, so 9 times minus 2 plus 3 times 12 plus d equals 5. So minus 18 plus 36 plus d equals 5. Bada bing, bada boom, I know that d equals minus 13. So if I was to rewrite this in the form written up the top, here's one I prepared earlier, knowing that a equals 1, b equals minus 2, c equals 12, and d equals minus 13. We can express this function here in this form. Now this is a cheeky question. This will take practice. If you didn't get this, the best way to have a go at these is to try. Now we're already on 14 minutes, so I'm going to have to cut this in half somehow. But anyway, we've still got one thing to do. Now the final rule we're dealing with, we've done a lot this lesson, and this will probably span out over 2 lessons, but is if x minus k is a factor of polynomial x, polynomial p should I say, then k is a factor of the constant term of the polynomial. For example, we're just looking at question A here. If I've got polynomial x, should I say polynomial p, equals x cubed plus 3x squared minus 4x minus 12, well then if I divide this by x minus k, I know that k is going to be a factor of minus 12. And so the first thing I need to say, well, if k is a factor of minus 12, then what are the factors of minus 12? The factors of minus 12 are, so we've got them listed here, minus 3 times 4, minus 4 times 3, minus 6 times 2, minus 2 times 6, minus 12 times 1, and minus 1 times 12. Any of these numbers here can be k. And so you know what I did? I just randomly choose one because one of them might work. In fact, several might work. Now, let's have a look. So what I did is I just chose minus 3. Let's have a go. So let's test. Let's let k equal minus 3. And so I did the function of minus 3. And what I found when I've substituted minus 3 in, I had 0 remainder. Therefore, boom, from what we learned earlier, it is a factor of polynomial p. And so, in that case, let's factorize it. What do I mean? Well, I'm just going to divide x minus negative 3, in other words, x plus 3 into the polynomial. Now, before you guys see the answer, which you probably have already, you guys can do this quickly yourself, but I've already done it because we're running out of time. And we see that if I divide x plus 3 into the polynomial, I get a quotient of x squared minus 4. Did some of you just go, x squared minus 4, what's that? It's difference of 2 squares. So polynomial x is just x plus 3 times x squared minus 4, which is also the same as x plus 3, x plus 2, x minus 2. This is factorising this polynomial here. Now, prior to this, we had no other way of actually factorising cubics and anything greater than that. Now we do.